Today we'll see the comparable comparator interfaces. Right. Before that, right, what is the why we need to go for comparable comparator? Right, we'll see that. Let me create. Here is the package. Page. Okay. Right, let me create one example. Right, if you want to sort, right, usually we will go for, suppose if you want to sort a group of objects, right, then if it is an array, right, we
We
will
are not
go.
able to see your screen.
No, screen not shared. Okay, let me share. Okay, fine. If we have a group of suppose integer array, right, we can sort by using our custom logic. We can bubble sort, right? Multiple sorting techniques are there. We can sort it, but in real time we will use a predefined classes only. Right, no need to go for our own. But in interview purpose only, we will go for only logics. Right, but in real time we will use a already predefined sortings. If you want to sort, suppose any array, we will go with arrays dot sort and then you can sort it. Right, if you want to print it, how will you print it? Arrays dot toString. Right, otherwise it will not print. We have to use the arrays dot print. Right, after sort, right, just if we print it, it will be in a sorted. All right, this is fine. Suppose if we have a one list, right, a list of string, we can create right, we can convert arrays data as a list. We can pass the comma separated value. We can convert into list. If we want to sort this one, right, this list, we can go with right, multiple things. We have collections, right, collections class, and then we can sort it. All right, it will sort it right in the alphabetical order. Now, suppose if we have right a list of employees, okay, list of employees. Okay, we'll create employee class. Okay, we can create the constructor. Alright, then just we'll assign the values string name, th. Then in the constructor, just we will initialize those values. And then we will right override the toString method to display the employee data. Right. We can create like this, right? Instead of creating employee 1, employee 2, employee 3 and add it directly, we can create like this. Arrays dot as list. We can pass the new employee. This is one employee, then comma, second employee, third employee. We can create directly list. Now, if you want to sort it, right? If you want to sort it, these things. Suppose I have to do. First of all, we will use collection dot sort. Right? What it will say. Right, sort list of type collection not applicable for the list of employee. It is saying it is not applicable. List of employees, I cannot sort, it is saying. Right, then what else we can have? Right, if we keep it, what is the tree set feature? Tree set, if we add anything, it will sort. But if we use tree set, right, but we don't have, I think, we don't have only list is there, right? Then we will convert list to set. Okay, how to? We can create tree set object. We can just provide this list of employees. It will convert to setup. Right. If we add any elements in the tree set, what we have learned, it should automatically sort it. Right. But it is a user defined method. It is a user defined method. What is happening? Class. Employee cannot be cached to comparable. Right. It is saying it is also I cannot class cached exception we are getting. Employee object cannot be cached to comparable. It is asking for a comparable object to sort it. To sort it, it is asking for a comparable class. Actually, employee is not a comparable class. Alright, it is also tree set also. It is unable to sort it or collection dot sort also not allowed. Right, then to sort, right, based on I want to sort based on names or I want to sort based on age. I want to based on salary. Right, I want to sort based on some of the field in the employee class. Right, then how to sort it? There are a two, two classes we have interfaces. Two interfaces we have comparable comparator. We have a comparable comparator interfaces. If you want to sort this. Right, now to define the user defined objects. If you want to sort the user defined objects. Right, we require a comparable comparator. By using that, we can sort based on some fields. Right, but if we take an integer, it is automatically right sorting. Right, previously we have taken string. Right, because why? String class implements comparable. String class implement comparable. Already it is implemented, but our class is not implemented this interface. That's why string automatically whenever you will add right a tree set, it is automatically sorting and collection dot sort also it is doing the sorting. All the wrapper classes also. Right. If we have an integer, right, all wrapper classes also already implements comparable. Right. That's why it is those are all automatically sorted, natural sorting order. Right. We'll see. There are two interfaces if you want to sort the our custom objects. Comparable comparator. Or a comparable comparator. First we'll see comparable. Right. Comparable is a used to define the natural sorting order. Right. It is used for natural sorting order. Right. It is a interface comparable. It has a one method compared to. It has a one method compared to. It will take one argument. It will take a one argument. Right. How it will sort? It will sort based on. If you want to sort means we require at least two elements. Right. If you want to sort two integers, two strings, right, two employee objects, we require at least two. If one is there, there is no requirement to sort it. At least more than one, then only it. Whenever we are comparing one with another, if it is returning zero means both are equal. Both are equal. Okay, what it will say internally, it will do. It will compare two objects. First of all, if you want to sort it means it internal, there should be some logic. That it will compare with one by one, two objects it will take, it will compare. That if returns 0 means both are equal. If returns a positive value, if the current object is greater than the past object. Right, we have a two objects. Right, if you returns the positive value if the current object is greater than past object. Right, we'll see that. Returns a negative value if the current object is less than the positive object. Suppose. Right, fine. We'll see. Just we'll see the example and then we'll understand more. Okay, now what we will do, we will take this employee class. We will first step is we have to implement comparable. Implements comparable. Right, it has a interface. Right, interface has a abstract method. Right, interface has a compare to abstract method. It is in which package? It is in java.lang package. Comparable is a java.lang package. It has a one enter abstract method. Mandatorily, we have to implement it in the right class. Otherwise, it will say compilation. We have to implement it. Right, add implement. Right, now we have to compare. We have to compare. Suppose I want to compare based on right either name or age. We will go with the age. Okay. Then what we have to do here? One employee object we will pass. Another object is what? Right. One employee we can. If we want to sort, we require two objects. Right. One is this one, and one more is we can have a this current object. This means current object, and then this is whatever we are sending. Right. This dot. Right. We can use. If it is a string, very simple one. Right. We can do this dot name. If you want to compare with name, this dot name compare to o dot name. It will like compare to will take care of everything. Right. We don't need to worry about it. See positive, negative, return 0, whatever 3 points we have learned, it will take care of it. Right. If both are equal, it will return 0. If first one, that is only we have learned. Right. Positive value. If the current object is greater than past object, then it will return positive. If the current object is less than right past object, it will return negative. If these are all two strings, it will compare alphabetical. Right, which one is a grade alphabetical order? Then it will return either 0 or negative or positive. Based on that, internally it will sort it. Right. Okay, we'll see. We'll see one by one. Right. If it is a string, directly we can this dot name compare to o dot name. Right. We have to modify the current class. Right. Comparable means we have to implement the comparable, and then we have to add the code inside class itself. Inside class itself, I have to modify the class code, and then we have to implement it. Right. Then now, suppose if I print it, right, before sorting, what is that? 30, 25, 35. Right. Now after sorting, is it sorted? We'll see. After sorted, is it sorted or not? 25, 35, 30. It's not sorted. Right. It's not sorted. Right. We have to keep it in list, array list, and then list directly we can collection dot sort. Right. We'll see. Collections dot sort employees. Right. Because, oh, sorry. I think it is sorted, but by mistake I printed something else. 1 second. We are sorting which one? Employees. Right, this one. We here printed something else. Maybe. Just let me check. Is it correct or not? Is it okay? I think it's not good. If it not, we'll go with the collection. I think it's not working. Right, directly we'll go with the collections. Collections dot sort employees. Collections dot sort employees. Right, now it's accepting. Right, previously it's not accepting because it's not implemented comparable. Now this employee is comparable object. Employee is a comparable because we have implemented it. Right. One thing, see, one thing I told you wrong, right? It is sorted preset also. But based on what we have sorted? Name, right? We are we have sorted name, but we are looking at age. Right. That is right. We have to look at names. We are sorting based on the names. See, previously it is John, something Elias, Bob. Now it is sorted based on names, Elias, Bob, John. Right. It is sorted perfectly. Right. I think tree set also it started, but we have seen wrongly. Right. A tree set. Then print this employee set. Let's see, it is sorted perfectly. Right. No issues. We can keep either in a tree set or collection dot sort. Collection dot sort. Collection dot sort means directly we can pass the this list object. Otherwise, we have to convert into tree set. If we keep it in a tree set, this list automatically it will sort it. Right. Employee objects. If you want to sort the user defined objects, we have to implement. First thing is first approach comparable. We have to implement the employee object comparable, and then we have to override the compare to method, and we can. This is based on the name string. Right now we will see this dot right age. Right here we can do multiple things. Right, with the age comparison, little bit, right? We can do like this. Here it is doing both. We require only integer, right? We'll see only with the integer. Okay. If this dot, right? Whatever we have learned, these three, but this is the old type of code, right? This is following these 3 points. Whatever we have learned, if return 0, if both are equal, return 0 if both are equal. That means both the objects have same data. Same data means we have to keep it side by side, right? Return 0. If it is a 1 means that means first object is greater than passed object. -1 means this object is less than the other. Right? Based on this -1, 1, 0, it will sort. Right, fine. Right now it will sort based on right age 25, 30, 35. It got sorted. Right. Either we can also use collections. Right. Collection dot sort employees. We can collection dot sort. It will also work 25, 30, 35. Right. Either we can use preset or collection dot sort. Right. Both will work. Right. We can also lambda expression. This one is later. We will see later this. Right. This is the first approach. By using the comparable, it's a natural order. We will call it as a natural ordering. And we have to change the employee class itself. Right. Wherever we want to sort, we have to implement in that class only. Right. I have to modify in that class only. Sometimes what will happen? We will get a jar file. Right. Some reusable code. Right. In automation also, we will get a framework code as a jar. In that there is a class is there. Suppose in that there is a employee class. But I cannot change that class. Right. If you want to use the comparable, I have to change the code inside. Right. I have to change the code inside. But if we want to do external, that means I don't want to touch it, but I want to sort it. Right, I don't want to change the code employee class. I want to do it externally. Right, then we will go for comparator. Right, we no need to touch it. Comparator means comparator is a custom sorting logic. You don't want to modify the class. Here we can write multiple sorting criteria. Here we have based on only one criteria. Right, here we have only based on one criteria. But here we can write multiple criteria. We can sort based on multiple criteria. Right. Okay, fine. We'll see. Okay, let me change this as a comparable example. Rename our file also. Okay, then comparator. Okay, comparator. Then we'll create a student class. Right. Here employee class will keep like that only. Then we will have a student class. Okay, student class. I will not implement anything. Here will remove. Right, fine. Now comparator example. Right here, what we can do, we can create a student object. What it has something student name and age, same thing. Right here, what we can do, comparator will have compare method. Comparator will have a compare method. We can implement a student, right? Comparator implements comparator. Comparator. That means it has a, what is the abstract method? It has compare method. Compare method. It will take a two arguments. Student one, student two. It will take a both arguments. It will take a both arguments. Right. Again, right, same thing, same piece of code we can write it. Right. For age, we can write like this. Right. Then otherwise we can write one more way, shortcut way. Right. Return simply with integer dot compare. Right. This is the latest. Right. Old way we can write, or it will take care of it. Internally, it will take care of everything. Integer dot compare o1 dot age o2 dot age. Correct, it will take. But here also see same thing we are doing. It is also now it is restricted to only one comparison. If I want to do with the multiple, right, on the age, on the name, on the salary, I cannot do it. That it is also, but the class is whatever we discussed. Class is in jar file, right? We cannot make like this. If it is outside accessible, then we can do like this. But if it is right, sometimes I want to do it on age. One class, right? One test class. I want to do a one test case based on the age. I want to sort. But some other test case, I want to do the based on the name. In that case, what will happen? I cannot change. If I change this code, that will affect. Right, existing test case will affect. Right, someone they want to compare with the right name. If they will change, what will happen? It will affect the existing test case. Right, that's why we will not do for the comparator. We will not do like this. Right, we will do external. We will not touch this class. We will do externally. Right, how to do that? Right, old way of doing is we can create one class, right? One class. Okay, like this we can create sort by name and sort by age. we can create a class like sort by name, implements comparator, right? We have to pass the student, and then override the, right? We have to implement compare method. Here based on the name, it is a called a something sort by name, sort by age, let's sort by salary, right? Like this, we can create any number of comparators. But for comparable, we cannot create, only for comparator. Comparable, we cannot create like this. Right, once we have done done this, then collections dot sort, right, then pass the, right, we have to pass the, right, this object sort by, create the object of it sort. Right, we have to pass it, right, new. Okay, now what is the issue it is saying? List of the method sort, list comparator type not applicable for the arguments, list of string, list of t, comparator dot sort by name. Oh, okay. We have taken string, right? It should be, right, my bad. Okay, we have to create the list of employees, right? That's why it is saying as list of employees. Right, pass the employees or student. Right, a student we have created, right? Students. Okay, students. Then pass the students object. Right, if you are not understanding, please let me know. Right, students. Just we have created object of students, a list of students, and then collection dot sort students, then sort by name. What it is saying again? Must qualify the allocation of enclosing new where extends comparator example. What is the issue? Sort by name, any semicolon mistake. List object only, right? Okay. 1 second. Where is the issue? Sort by name comparator students. Okay. Is it something missed? Any bracket? Here it is closed. Here. No enclosing instance of type. Oh, okay. Still it is saying error. What is the error? I'm not getting what is that. Okay. Okay. I think we are without static. Okay. Without static, it is not allowing. Okay. Okay, just make it a static. That's fine. Right inside, I think static right inside. Same class we have created another class, right? I think it's not accepting. That's fine. Right, we can pass the this object of it new sort by age. Right, then we will see just print it. Okay, it is sort based on the right age, right 25, 30, 35. Right, similarly, if you want to create right a student by using the sort by right static class sort by name, just we can implement it, and here just logic will change. Right, if you want to later in some other class, I want just we will change sort by name. That's it. Right, sort by name. Right, now it will sort by name. right? Simple thing, right? Instead of creating these classes also, right? Instead of creating multiple classes, right? It is also we have to create multiple classes, right? Instead of creating these classes, we can also do, right? We can also do, right? What we can do one more way, anonymous inner class. We can create a anonymous inner class, right? We will learn inner classes later, right? Just anonymous inner class, this is called. How we will here directly we will create, instead of creating class and then create object for it, instead of that, anonymous inner class, new comparator of, open the curly bracket, and then override the compare method. Override the compare method. It will take a two arguments, right? Here we want to compare integer dot compare. Integer dot compare s1 dot age, s2 dot age. Right, same thing. It will also do. It is called a anonymous inner class. It will also sort 25, 30, 35. Suppose if you want some other class, right? I want to use collections dot sort by using name, maybe, right? First we have to pass the list object, then new comparator using name, right? New comparator of, here just logic will change, s dot name dot compare to s2 dot name. Right, just we have to change this logic, right? Wherever we require just anonymous inner class, we can write. Right, after came to lambda expression, this got more simplified. Right, this got more simplified if we use the lambda expressions. Right, fine. Collections dot sort, see, simple thing. Collections dot sort students comparator dot comparing int. Comparator dot, this is called a method reference. Right, there are multiple ways we can do the with lambda expressions. This is one of the simplest way. Comparator dot comparing it. Yes, this is the first object, lambda expression, second one. Right, it will also do the same thing. Right, if you want to do the on the name, right, comparator dot comparing, right, as just any name, we can give some reference variable, that's it. S lambda expression as dot name. Right, or there are multiple ways we can do it, right, multiple ways. Let's see, it's not applicable here. One more way. Collections dot sort students. Instead of this, I think we'll do it like this also. Alright, this is the old way. S1, S2. Right, we have a two objects. Right, what we are doing here, we will explain more in the streams, right? Interfaces concept, functional interfaces concept. I will explain more. Here, just we are removing this. Right, here, this one. Right, this part is we are removing this part. Right, that is S1, S2. Right, no need of a student also. Then we are keeping lambda expression and then integer. What is the logic here? Integer dot com. Right, this can be somewhat we can remember. This is right, somewhat difficult to remember these syntaxes. If you are right, these also we can do it. Here we are replacing this. We are replacing. We are keeping S1 and S2 and the lambda expression integer dot compare S1 dot is. If it is a name, name S1 dot name comma S name. Right, like this. This syntax we will change. Right, that means by using the comparator, we no need to change the existing class, right? We can do actionally. We can sort based on multiple fields. We can sort based on multiple fields, right? It is comparator is in util package. Comparable in, right? Sometimes the differences they may ask that it is in a java.lang package comparable. Compare to is in java.util package. Comparator is in java.util package. Right? Comparable, you have a compare to method, which will take only one object. Comparator, it has a compare method. It has a two arguments. Right here, we have to change the logic inside a class itself. But here we can create multiple classes or anonymous inner classes, or we can use lambda expressions to do it. We no need to touch the class. Right here, single default sorting logic, right? Only one sorting logic. Here, multiple sortings, we can write it. We have to modify the class in the comparable. Here, we no need to modify. We no need to modify comparator. Right here, we have to use comparable collections.sort, pass the list object. Right, it will take only list object. Collections.sort will take only list. Collection.sort. For comparator, we have to pass list and what is the comparator? That we have to pass the compare. Right, when you want to use comparable, when you want natural sorting order or default sorting order, comparator when you need multiple custom sorting. If you know only one logic means, then directly we will go for comparable. But sometimes we want a multiple sorting logics I want based on different fields, then we will go for comparator. Right. Either we can use collection.sort or treeset. Right, both we can use. Right. Okay, that's it for today. In the next class, we will see equals and hash code. Right. What is the use of equals and hash code? So far, any questions? Are you able to
Sir, this
understand?
is
Right.
applicable only for the user-defined objects, right? Like whatever a user. Uh,
Right. Right. In interviews, mostly in for other types, suppose wrapper classes are there, string is there, directly they will sort it. We no need to do anything. Collection dot sort. If you pass that list, right, list of string, list of integer, list of boolean, right, it will sort automatically. We no need to worry about it because they have already implemented comparable interface only for user defined. In interviews also they will ask. Suppose they will, what they will do, they will ask, I have a user defined objects. If I keep it in tree set, whether it will sort or not, whether it will, right, automatically sort or not. Right, it will not sort. How it will sort? Because it, you know, it is not, it is our class, our class. So it did not implemented comparable or comparator. So it will not sort. We have to do, we have to sort based on, right, it, we can say in interview, it will not sort because it will not implement any comparable comparator interface. We have, by using the comparable comparator, we can sort based on any fields. If they will ask any code, sometimes they will ask write down the code. Right, we can write comparable or comparator. We can explain. Right, this is for user defined objects.
okay, sir.
Okay, fine then. If you don't have anything, we are good with this meeting. We'll meet tomorrow.